and welcome! I continue digging through the donated mainboards, and today I want to take a look at this very nice mainboard, which had quite unique features and was superior to most other competitors of the time. The mainboard is very dirty, covered in a mix of oil and dust. It is obviously a socket 7 board and is based on the glorious Intel 430TX chipset. This was the fastest chipset Intel produced for the socket 7 platform. On the back we already see the QDI sticker, the mainboard manufacturer which not only produced high quality products at the time, but was also often ahead of its time. This board is a QDI P5I430TX, codenamed Titanium IB. One of the best socket 7 mainboards in my opinion, but before we talk about its features, let's take a closer look at some obvious defects. First of all, most pin headers for turbo, reset and power buttons as well as LEDs and speaker are banned. No problem, I use such a tool to straighten the pins. I already got a couple of times the question what this tool is. It is usually sold in sets with other tools, and if you search for a soldering tool fork, you will pretty fast find what you need. It is definitely a very handy tool. Okay, the next problem is a broken 72-pin RAM slot. On the second slot, one hinge is broken, but it is not critical. The metal clip will still hold the memory modules well in place. Luckily, there are also two 168-pin SD-RAM slots. The two lower 72-pin memory slots seem to be okay, but to be honest, they are not really needed. The SD-RAM slots are a better option anyway. The upper two 72-pin RAM slots can be replaced, but I have to look if I have replacement parts at hand. Maybe desolder those from other broken boards in scrap. Another very minor damage is this plastic IDE connector. Nothing to worry about, otherwise I don't see any damage. At least nothing jumps into my eye so far. The board is just very dirty and sticky though. The bad thing, which I don't like about it, is that the BIOS chip is soldered directly to the PCB. It is fixable of course, but would be better if it would be socketed from the factory. Just in case a BIOS update goes wrong, it would be much simpler to write a new BIOS or experiment with another versions just by switching the ICs. Well, we have what we have. On the back everything looks clean and in good condition. However, I noticed a very nasty issue which you always should keep in mind. When old hardware gets stacked or thrown into a bin, the longer pins of the components can be bent towards each other, ending up shorting something. Like in this case, multiple pins are almost touching each other. Would be probably enough to add some more pressure, inserting an expansion card for example, and end up shorting something. Otherwise, on the back of the board, everything looks great. Now let's talk about the features of this board which make it so special. First of all, this board has a switching voltage regulator for the CPU power supply. You can always recognize those by the coils. Today, nothing special, but back then these boards were pioneers, and previous generations usually used much less efficient linear regulators, which produced a lot of heat and were not really suitable for CPUs over 166 MHz. This solution remains barely warm, even if you try to run a 500 MHz CPU in it. This feature was very future-proof, but was not really unique for the mainboards with 430TX chipset. So what is then so unique about these boards, you may ask? Well, unique is that we have here one of the first boards with one feature which we are absolutely used to today. It has no jumpers for the CPU voltage, clock and multiplier. Everything can be set via software in BIOS. Just drop in the CPU and you are good to go. Totally normal today, but almost 30 years ago it was a mind-blowing technology. Want to overclock or undervolt your CPU? No need to open the case. This was revolutionary back then, and QDI was one of the rare companies which provided this feature under the name Speed-Easy technology. Well, let's give it a try. Here I have a Pentium MMX 233 MHz, the fastest desktop socket 7 CPU from Intel. It is specified for 66 MHz frontside bus, 3.5 multiplier and dual voltage at 2.8 volt, respective 3.3 volt for the I/O. As I said, no need to set any jumpers on the board. After a jumper hell, which we were running into especially on 486 systems, this was a blast. Before we start, let's check for shorts. Looks good. Now let's add a post analyzer card, turn on the system and see what happens. That sounds promising. The board is missing the memory, which is right. Time to test the CPU voltage. If the board would give single voltage at 3.3 volts, that would harm the CPU in the long term. 4.8 volts. I'd expect 5 volts here. I think this is the input, though slightly too low. And here we have 2.7 volts, also 0.1 volt too low, but still within limits. Okay, we would definitely need a CPU cooler for the further tests. The Pentium MMX 233 gets quite toasty. Nice is that on this board we already have a pin header for the CPU, which was also not very common back then. Middle pin is 12 volts, both outer pins are ground. Doesn't matter which way around you put in the fan connector, the polarity is always right. As for memory, I have here two 32 MB as DRAM modules. I think they are 66 MHz, but that should be enough for now. I don't plan to overclock it yet. Of course, we should use some dioxide first, especially on such a dirty and old board. Okay, the fan is not spinning. And we have no bips whatsoever. Let's add a graphics card. It should actually beep, expecting a video card, but maybe this BIOS variant is not like that. Oh, and I disconnected the CPU fan for now. Let's come back later to it. And we have a beep. Also the output is working and we see that glorious Speed Easy logo on the right. The CPU is shown as a Pentium 100, but this is the fallback default settings and the proper settings have to be set in BIOS. We also have 64 MB of RAM, which means that both SD-RAM slots are working. And in BIOS we have here an unusual entry named Speed Easy CPU Setup. And this is the most interesting about this whole mainboard. In this menu you can either set an easy mode and just select the final CPU clock between 100 and 233 MHz. Or you can switch to jumper emulation and set the frontside bus and multiplier manually. Frontside bus can be set up from 50 MHz up to 75 MHz. Don't know what means 60 plus. Well, we have a 233 MHz CPU, so 66 MHz frontside bus and 3.5 multiplier. It even shows you the BF0 and BF1 CPU pin values, which would jumpers usually set. Yeah, and also CPU voltage can be set. Again, manually or automatically. This CPU requires 3.3 volts for the I/O and 2.8 volts for the core, as I told before. After the first reboot, it looks like the BIOS settings were not saved. The battery is not installed yet, maybe because of that, but at least this time it shows the message that a new CPU has been installed. Okay, here the clocks are reset again, but funny enough, the voltage is now set to auto, despite that I left it at manual last time. Anyway, let's set everything once again and give it another try. And yay, we have a MMX at 233 MHz. Let's add a compact flash to IDE adapter and try to boot into DOS. Looks very good so far. Yeah, with 233 MHz it should be about 3.5 times faster than a Pentium 66. This seems to be right. And Doom is running as well. That is great. 826 points. That is around 90 FPS. Not bad. Okay, before doing more tests, we have to get the fan spinning. Let's see. Still nothing. I know this one is working, but let's try another one. Also nothing. This is strange. The voltage shows 12 volts. Okay, these pins are both ground and are connected together. This is fine. Now the question, where the middle pin is going to. Right, here is a resistor. Let's see where the other end of that resistor is connected to. And it goes directly to 12 volts from the PSU. So there is no other way except that this resistor is dead. Strange that it still shows 12 volts. Probably it still has some kind of connectivity, but not enough current can pass through. When looking closer, you can even see a black spot in the middle. It is definitely dead. Funny enough, it still shows some resistance. Over 430 ohm. That is too much. Now it shows 214 ohm, 196. It's very flaky and needs to be replaced. But first I'd need to clean this board. It is extremely dirty and that can even lead to system instability in the worst case, because dust can get slightly moist and start to be conductive. So time for a good wash. "24 hours fast forward and the board is clean again. However, during the wash I discovered a trace which looks like it's burned. Can you see it? Here. This needs to be checked out in detail. Unfortunately, I didn't find any spare RAM slots, but as I told, those 72-pin slots are not really necessary and not worth the effort of desoldering. I just used some plastic model glue to fix it. It melts the plastic surface and holds the things quite reliably. Some paper to press against the slot as long as glue is drying. Now let's take a look at this trace under a microscope. This looks strange indeed, like it's burnt, but the trace underneath seems to be okay. Let's clean it and put some solder on top to strengthen it. So, looks much better. A little bit of nail varnish for protection. Still don't know what it was. Maybe some chemical reaction with something what dropped onto this board? Who knows? Now the fan connector. As you see, the resistor has indeed a burn mark in the middle. And it actually broke into two pieces. No doubt that it was the culprit. The original resistor looked to be a 10 ohm one. It would be also possible just to bridge the contacts and go without the resistor at all, or just use a 0 ohm one, for example. But it's good to have something there to avoid any possible shorts on the 12 volts rail. Unfortunately, I didn't find a 10 ohm SMD resistor, but found this 68 ohm one, which is hopefully a good enough replacement. The CPU fan tells that it draws 0.9 watts at 12 volts, which means it has an approximate resistance of 160 ohm. With a simple voltage division equation, this means that with 68 ohm resistor instead of 10, we would get lower voltage, around 8.5 volts on the fan. What would make the fan a bit more silent. However, that also means that the resistor would have to dissipate about 0.2 watts as heat. But I guess that should be doable. Back to business. This time let's go with this Pentium MMX 200, which already has a heatsink with a fan glued on top. I'll use the same RAM modules as before. By the way, it is interesting that the boards of this age had slots for different memory modules. This is because back in the days memory was expensive and the manufacturer wanted to give the opportunity to the users to use the memory which they already had. This board supports both EDO and FPM memory as far as I remember, and so even FPM memory modules from later 486 systems could be reused here. That would have saved you a bunch of money back then, but when building this system from scratch, there was no need to avoid using faster and bigger SDRAM modules, especially today where such memory is very easy to find. And the fan is spinning. It is running at around 9 volts, not quite at 8.5 from the previous calculation, but I guess that the numbers written on the fan are just not quite precise. That was an easy fix. Let's add a new coin battery, so I don't need to set the BIOS settings all the time. And the system is still running. Nice! In Doom we are getting now 866 points. That is just about 5% slower than the 233 MHz CPU before. What else can be done to call it a success? Well, I updated the BIOS. As I said, unfortunately the BIOS IC is soldered, so it has to be updated from a running system. Luckily, the latest version of the BIOS can be found on the RetroWeb project. I copied the related files onto the compact flash card and started the flash procedure from the DOS prompt. And after the restart, the 1.3S was smiling at me. Unfortunately, this didn't add any new features in the BIOS, especially in Speed Easy area. All the settings are in the same range, front-side bus from 50 to 75 MHz. Still don't know what that 60 plus means. Age? Well, and the multiplier is up to 3.5. The sad thing is that the range of voltages goes only down to 2.8 volts, which makes it not really usable with AMD K62 CPUs, which needed 2.2 volts. That is unfortunate, but maybe other voltages can be added into the BIOS. I'd have to analyze the voltage supply circuit first to tell if it's possible at all. However, for everything up to Pentium MMX 233, this board is awesome. Very high-end for its time, don't you think? It is especially handy if you need to test a bunch of different CPUs. Just drop those one after another into the socket and start the system. Have a dual voltage Cyrix 6X86L PR166? No problem, this mainboard detects it, sets the voltage properly and even allows to overclock it if you want. Want to switch from a dual voltage CPU to a single voltage AMD K5I430TX? No problem again. Speed Easy goes automatically into the single voltage mode and sets it to 3.5 volts. When I go back to a dual voltage Intel Pentium MMX, Insert the CPU and just use it. Different manufacturers, different designs, different voltages, just works. No need to look into the manual, searching for jumper settings and trying to understand which of those has been set wrong. Beautiful. However, as I mentioned before, it has one unfortunate drawback. This board doesn't know any Super Socket 7 CPUs like the AMD K6-2, and since the BIOS is not quite standard, it is a bit more complicated to add that support. Especially the required lower voltage down to 2.2 volts is not possible out of the box. Of course, I tried to run an AMD K6-2 briefly to see how the board would react, but it couldn't detect the CPU properly. Rebooted every time as I was trying to enter BIOS and applied 2.8 volt core voltage instead of 2.2 volts. For a short time the CPU would survive it, but it's not healthy in the long term. Would be really nice to add AMD K6-2 support to this system, but maybe this is a topic for another day. And this is it for today. Just as always, thank you for watching and goodbye.